Welcome to the TheCellBeyond Game Engine tutorial. In this video, I will show you how you can set up movement for your character like this using the stay engine and the controller component for the character body to the classes. Okay, so let's begin. So first, you likely need to get the engine if you haven't. I will put a timestamp below the video for when you can skip ahead to the coding. This section will be for the new user who just found the engine. Okay, so to get the engine, you can find it on my GitHub page. You can read more about it here and some small guide I put here. I will finish the wiki in some time in the future. To build the script, you may need the dedication file or Java development version 25. To run the engine on macOS, you need to execute this permission grant command because I don't have resource to side code or format. Okay, so to get the binary or the executable, you need to go to release. And the current version I will make the tutorial is version 1.8.1. There's a dot for Linux, macOS, and Windows. Okay, when you unzip the download, there will be the exe executable for Windows. For Linux, it's an application, and the same for macOS too. So you just need to duplicate. Let me set the size here for you. Okay, you will click with this panel. So here is the welcome panel. You can open an existing project here, or you can open an existing project also via here too. This is so you can select this. This is the recent project, and you can create a new project here. And for this tutorial, I will create a new project under these folders where I put all the tests. It call it tutorial. Select and then click it. Select the folder. Say selection directory is valid here, and title is the name of your game project. It's a whatever you like. And this thing I will leave a default. You can change it later in the editor. Let's create the project. Quick. Okay, so we enter the main UI. You can quickly create new scene here. You can choose scene type. These are the two command scene type and in scripting. This is where we will create the script check later. You can also manage some scene here, open scene here, and you can choose scene if you have. If you don't have any visit, ask if you want to create a new scene here, or you can click this button. You can edit, create, or click this here too, and you can save here, the shortcut Control S. Okay, so for the earlier thing you saw, you can click on project, the reference. This is where you can generate extra detail about your project like physics layer, rendering, texture scale, and clear color. This is the default background color. You can change it here to the color you like. Okay, you can see it here or here too. And this is the script tab we will explore it later. And the input map where you can add new input action binding. We'll come back to that later. Okay, this is the quick section. So you can create a project and catch up to us. We will go into creating the movement for a character now. Okay, so we can start with creating the script now. Okay, first let's quickly create a 2D scene and rename the root object to something short. Okay, and we can save the scene. You can quickly double click it to save like this and call it scene one real quick. You can also double click it to rename later in the scene control here. Okay, so then we will click on the script scene and edit scan directory. Um, if you don't use that, you can use project preference and click the input by the script tab here. Okay, so in scripting scan directory, you will need to create a script project for it. So let's generate this button to generate. This is what the engine generate first. Okay, and you can take that part and go to the folder here. This is what it generate. It generate a Gradle project for Java, and in this tutorial, I will use IntelliJ. I need to write the script in. Yeah, you can use other IDE if you want. The setup might be a bit different in there, like how you set up your Gradle in Java and other stuff. So okay, let's open this folder and IntelliJ project. Okay, so it finished loading. You say it is recognize the source. If it doesn't for you, you need to go to setting and in the build execution and deployment, you go to the build tool section, click it, and then you select Gradle. We use Gradle for this. Then your distribution, you need to use a grabber. The distribution grabber, which is included in the project for us, so you don't have to install Gradle again. And for the Gradle JVM, the Java Virtual Machine for it, if you have not installed JDK25, you can add it from this if you have it elsewhere, or you can select download here, select version 25, and from Eclipse, Xamarin, or anywhere else that you want. Select the path for it. I already have it, so I'm not gonna download it again. And you need to click apply. It might need to sync and build again. That's okay. This is you can start writing your script in here now, but I don't recommend it because this is the default package. You can put it in down in the package. This is the name of the package is up to your organization. Call it character for the object. Then we can select new again and create a new Java class. The name of the class is up to you. Um, in this tutorial, I will borrow Aula from the game One Shot. So I will call the class her name. Okay, and then we will extend the character body to the editor suggested for you. You tab it so to complete. And we will need to use in the editor, especially with the add new object here. So we need to annotate it with register game object. You can also add the custom label like player object and custom description in one player control object like that. Let me close this here. Yeah. Um, you can add label only or description only and both like this, or you don't leave it at all and leave it empty to default. Okay, so let's add this right now. And then what we do is go to this right tab on Gradle and then in task here in build, select jar. Run the jar, just double click it, say jar successful. Okay. And in our engine, let me clear this log here. In scripting, we will press reload script. Say low one custom game object type was, and then we can click any object. We say player object, player control object right here. So that's it. Then let me move the label so it back to the default class name. And when you change it, you need to jar again. We're basically building a jar file for the script. See the name change. Yes. You can create the object right now. Yeah. See right here. Okay. So for this specific character, her control mode is floating, not grounded. So we select floating right there, and we can close it here for now. See, we need a component for animate her animation and the control. So first, let's get her assets first. Let's click on this resource panel and in reprice tab, click at this dialog pop-up, browse file, and I put her resource here. So we quickly select that. Then you need to enter the information like number of sheet, the sprite number of sprite per sheet, and the width and the height of sheet, the width and the height. There are also optional spacing if there is an offset start position. I might add a end position in later, but that is for future expansion. We this next session is for organization. So has the name of the sheet and the category that you put it under. Let's add that. Okay, so in you will create the animation. Select this animated sprite. This is for the animation. For the name, we'll rename it to let's see, animation for short. Okay, and from here you can select add new animation, or you can click here to get the full auxiliary panel. You would open it anyway, and then you click a new animation. Yes. So for all of our animation, it needs to be loop. We can leave the FPS like 5 for now. It not matter for the tutorial yet. And then, so we don't have to rename it too much, we will append the refix walk like this. Uh, these names are up to you. I choose walk up, down, left, and right. So I will add refix like this. And then we will duplicate the selected animation. 2, 3, 4. Oh, wait. Yes. The prefix add a hyphen by itself, so maybe just work like this. Work 1, 3. Okay, for now, it's work, and we can start rename this to the correct name. Oh. By the way, you double click on it, and you press enter to accept edit. You press escape to cancel edit. Like you did, you press cancel, it will revert the name back. Left, right, right. So next, we need to add the animation. Um, start with that first. For now, you need to manually drag it in. Just click, hold, and then drag it. You can change the order of these by select here, select a frame, and move it left or right. Okay. You can also delete it like this. Quick delete. Yeah. I will improve the control in future version. Animation should be done for now. these names we will be using them in the script. Next, we will create a controller for it's also a component. Click on the inspector tab here, click add new component again, and then we'll select controller this. Okay, so for the controller, the control mode is spatial or physical. Since character body today is a physical, we need to choose physical. Otherwise, it will only move the it won't be able to move because the rule of the engine is that physics dictate over spatial if physics is. This movement speed here is meter per second. Let's say 1 meter per second. Okay. And then you can click here. Click to open auxiliary editor panel if supported. It's a here. Let me close this. So both animation and controller have auxiliary panel. So you can click this here, and then the same here. You can create the binding for it. For the up, we use the command direction up here, and activation mode immediate. Hold tab, we use immediate. The hold is mean how much time required for activation, and the tap is only activate when the user tap. So when they tap, they press and hold uh, the input binding is deactivate on the next frame. First, we will use immediate and the right. Okay, so next is the bind input action. So the controller binding instead, you need to add input action to activate it. So I have set up these previously. I will show it again. So in the edit input tab, let me delete the and add it again. We will create new action. I say we need for action for. Okay, so you can rename this by double click and press escape to cancel, enter to accept it. The same way for the binding and the ammunition name. So and then you click on this plus here to add new key combo. So it's key combo means you can use more than one key or mouse button. In this case, we only need one, so press the wait, and it should do this again. So you can see a you should click here, so it changes to listening for input. Then you press down to confirm it. Or we should expand so we can also add more than one input. For example, S is also down, so you can press down or S to move down. Oh, and if you press something right, you can also press it to edit the key combo too. All right, that seems about good. Okay, so back to this panel. So up, we will bind it to the move up button. You can bind more than one button. You can sort by name here, and you can also create a short term. And to remove a binding, you can click this to unbound it. We should move to scripting now. So we select this panel again, and then we go back to our scripting project here. Let's quickly add the code for it. Is the override. Okay. Is a protected for on physics update. Then we pass the data time in. Okay, so the a shortcut for here is I think it Control O. Yeah, Control O to override implement. So you can select what method that you want to override. Okay, let's move on. Let's call the method that we're supposed to call. Moving slide. Okay, so moving slide just basically similar to callout. You need to call it so your character move. Okay, so let's run the jar again, and then in here we will reload script. Reload the script is a low one to stop. Let's clear it and start again. Yes, so she moved out, but the animation doesn't update. That's okay because we haven't add code to drive it yet, and we will do that right now. So backend for the animation. So for the animation, we will need a direction to control that. You can use the raw velocity, which is this value, velocity dot x or velocity dot y, but you should add an enum for it to be clear. That's if you are adjusting the control direction. So add public enum direction. This is up to your name. I call it direction. You might call it something else. You also can write in a different class. In that case, you will need to import it in. Let's say here, take for example, Java class, Java, wait, Java direction, and you select enum. And then in here, you when you use it, you say public Java direction, tap it to add, just like that. Similar here. So we don't need that direction. So she have 4 directions. Once again, this is up to your name. You can name this however you like. Okay, so we will need a reference to this component. So I will show you the way that I recommend you do it, which is using hierarchy path. For that, we need a reference to the part of the component. We attach this animation directly to the object, so it's an immediate path. So sorry for clicking on that. So public final, so it can be edited. Final string, we call it animation path constant, and for this we construct a object name hierarchy path dot component delimiter, or you can select up component hierarchy path up component to build a path here. Yeah, so get hierarchy path represent the given component. Here you can create a hierarchy path, and then we can use hierarchy path directly, or you can use the string version of it, which is also fine. Okay, so we use hierarchy path dot component delimiter. You can write in the string manually, but I suggest it you is constant, so your script doesn't get outdated when the engine API change, for example, the animation. Yes, the name seems correct, and we will check that with a quick animated sprite render for this animation. This is the field that will store the component when we get it, and then we override texted void on ready. This is equivalent to the ready function in if you use Gradle. So on ready, our animation, we will get it with hiking path. So you first cast to the type, sorry, then hierarchy path with the S. You rest tab so it auto complete for you like this, and then you select two two component. We will use the version that require context. You can also use absolute path it if you show that the same instructions chain, but for now, use this. So we know that immediate relation that we define. So for this, we'll pass the first thing in the path to the component, and then this is the context with the game object that hold the component. This hold this component. we'll see this for now. Let's say we change this name with we change the name, well, add a one to it. Okay, and we have not updated this yet. So let's build it. Jar case runtime below, and when we press play, it will display a warning that it cannot resolve animation to component because it does not exist. The name does not the same anymore. Okay, so you need to watch out for that when you rename it. You need to update the script or fix the name in the editor again for the object. Okay, press stop. Change the name back. Okay, and when press play again, no more error this time. Okay, so that's the code to try her animation. Now we should start adding the stage. For that, I will create a new package here called stage, and then we will create an abstract class. You don't have to do this, by the way, but public abstract. But it's basically the base class that hold the field that all the child class set or the subclass types here. Object abstract stay. Oh, I created the wrong type. Select that. Class not compact saw. Okay, not compact saw. Right. Sorry. Wait, I'll do last. Okay, extend the stay class. This one. Okay, and basically we want to implement a reference of this object, the object that we want to control into the state. So we create an abstract class so we can enforce the constructor of the state to take up the object reference, the parameter, and then we can create the constructor for it, public state. Okay, so then we can start creating more stage for her. You can press on enter and image to set create constructor. You accept that. It will quickly create the constructor like that you want. Next is our transition priority. So stay have transition priority. Let me click on that and click to inspection short for you. So yes, stay have transition priority. You can read the document here for more detail. A stay condition met a check if the stay can be entered. So for this stay, we want the condition to return that the dot velocity equal to 0. So yes, so basically we want that when her velocity zero out, she can return to idle state. And on stay enter, we can update the animation to whatever it is later. We will do that later. That's we quickly create on stay class. So for her, the on stay condition is that she zero out her velocity, and when she enter the state, we need to stop the current animation of her. So why is it like that? Because in this specific setup, the first frame of the animation is also the this frame zero, the first frame. It also the idle frame of the animation. So that's why we can do it like this. Some character based on your design and the artist design may have a delicate idle state with different animation when they transition idle into idle. So you need to handle that based on how the sprite and the animation is set up too. In this case, the idle is first of the animation, so we just need to stop the current animation. So we do the check dot animation not no, so it doesn't throw error. Oh wait, if sorry, two what? Then animation dot stop. Let's stop on the animation. You might want to add a tracker for the past day also. So private uh, direction, 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 past direction. Only to that, but on stay enter, the path direction will equal to that of our current direction when we enter. Oh wait, did we not add that a public? Okay, we have not added a field yet. Let's add that field. So public um, direction, direction, and we initialize it to her default direction. So by default, I will select down a starting direction. We can add the export annotation right here. So this is export out of the editor for you. There's the optional label and optional description too, and type in case the editor recognizes right. For now, we will only need the label. That's a sensor slap, and we can. So now we can use the direction map like that, and right, we will need to provide the direction. So let's add a method for that. Void, let's say right direction. So this method will use to update her direction based on her velocity, which is what the controller used to apply movement to our character. What we do is if the velocity y is right. This is basically our update priority for X. We want prioritizing the vertical direction over horizontal. Why we check it like this? Because in this setup, when the character enter idle state, their velocity will be zero, but they will keep the direction that they were looking at before they enter the idle state. It is specific for this setup only. Your situation might be different, so make sure to check out how you set up your animation and control. But for this case, we do not change the direction to anything if there is no velocity. And on physical day, we need to call this right direction in here. We also need to update the starting animation. So the reason why is we add this field here. Wait, I actually need to reload this. Okay, the script should start to compile. Gradle, jar, still compile, right? Yes, it's still compile. And when you click it, yes. So basically, we export the direction field. So our character can start out in the direction that we want. For example, maybe the scene that we want them to look down toward the screen, or on the next scene you want them to be look up. Like for example, when they enter the new scene from the bottom and they are walking toward up out of the toward up. So that this is for the starting direction of the character when it's created for the instant. Start. So we need code to write that too. So we'll add a public is a public method, so we can share it with our state later. Some of our state will be using that. For example, the idle state, up voice, update animation. Okay, so we don't need to take anything. Then we check here if the animation that we get is no, we do nothing. So no pointer exception. And then we will call animation, set current animation, and we perform the switch on the direction. Let's finish that. And then we call case up, and this is where the name of the animation is typed in. So you can create a constant for it like this on here. So I create the constant so you don't have to type it again. All right, so we add a constant for it. We will pass this constant. And on ready, we also might want to call this, but I'm not sure if it takes any uh, effect. Maybe call it anyway. Um, the animation. Yeah. So that's that. And seem everything seems fine. Back to the idle stage. Oh wait, I was writing this on the wrong class, so sorry for that. Oh, I didn't realize. Yeah, I was writing this on the wrong class. So move those back to the idle state, which is where this is needed. Private direction, pass direction. Let's create that again. Idle, and we will insert override first. Okay, we will want state punishment, state enter, and the update. Okay, so the condition is basically the same. Is return the if the velocity equal to 0. Yes, and on state enter we will update our past direction with the current direction of the character, and then we will check if the animation is not null, then we call the animation to stop. And then in the update method, what we will do is we say, okay, so if the past direction is different from the current direction, why actually no, let's invert this. So like that, if not return, then we say that then we will call, sorry, then we will call the update animation. Before we do that, we use the path direction. And for the down condition, we will check if that the direction. So I'll dot direction equal to down, and the velocity on the x on the y-axis is less than 0. So the second check y less than 0. So basically if you are idling in the down state and velocity, we did not check for velocity. It means that we can switch back to the down moving state again. So that's the problem. So we need to check for velocity. So if there is velocity, then we can leave the state. like that. And on stay enter, set the current animation. Wait, no, we can't play, sorry. We can't play animation, and then we pass the work by the call it alula dot yeah, like this, the work down animation, and then we should hit it for the rest of the stay then. New class which will be the stay engine that drive this. Now you need to be mindful when you create the stay engine because stay engine are serializable, so you can actually save stay into the scene structure. So you need to be careful with what you are saving. What I'm doing now is gonna extend the stay engine, and then we're gonna implement the not serialized component. It's disable serialization for this component and unrelated data. If you don't do it this way, what you need to do is be mindful of what you are storing inside the state. So for example, in the idle state, we have this here. Um, so if you don't add the serialization interface, you need to add a transient in here. Basically, the keyword transient is telling the serialization to not store that in the scene, and that field is either be created by your script, your logic, or generate new by some engine internal. So that's up to you to control. I do it this way because it's clean and I don't have to be writing transient a lot. For this one, what you do is override the on star, the protected void on star. So basically, when this component is starting, if the game object that's a owner of this component, there's a field on the component, so you can find it correctly. We check an instance of the character class that we want to check, and then you can execute if it's correct, or you can invert the condition. We invert the condition. So basically, if this is attached not to this type of object, we can return a link and do no further setup. But if it is correctly attaches, then you will adjust this so auto enable auto transition is true, and then we starting adding stage. So state the name is idle, and we will create a new, we call new app state. Then we pass up the object inside this object, which is what we define in the abstract class earlier. Okay, so that's a register the stage, and then we gonna set a default state. So if something got wrong, the character default to that stage. Or basically the starting state also. So default state, we use the idle name that we give it earlier for the idle state. I forgot to set the priority. So since we are using the auto transition machine, we should set the auto transition priorities. I think this should work now. Let's add it to the object to check it out. Since this is not a zero-line component, you don't have to annotate it with the tool, so you can add it in the scene. Usually, via the editor, you add like this register component. But since we make it non-zero line, so we don't have scene into the scene structure, it needs to be created via script logic. So we don't annotate at that, but in the character class here, we will override the on star, override protected void on star. Okay, so on star, and then we will add component, and we call new engine, and that's basically it. So let's try it out, see if it works correctly. Okay, and reload script, and let's play. So, oh, sorry. Yeah, you can plainly see. Let me certify. Yeah, you can plainly see her move. Let me adjust this by first adding a camera. Oh wait, this is for component. Now here, camera 2D, create, um, move logic frame. We will zoom in a bit. Let's say 0.6, 0.6. And then we enable position smoothing. On the object itself, you can add a remote transform. This is basically similar to Godot. We will disable rotation. We only update position, and we will drag the camera in the target path. Now this use the absolute path, but if you change it, you worry. You can use the root key itself. Here it says it find it correctly. You can use root as well. And let's try if see it work. Okay, so she move, but we don't have frame of reference. How she look like? So quickly add something static into it. Yeah, let's be sure we do nicely. Let's add direct to the world. Some bright renderer like that. Drag it in. Transform, and we scale it down a bit. Like one, four, four. Um, should move somewhere here, maybe. Yeah, like that. And for Z and that, for Z and that, so this does not overlap. Um, we can ensure it by pump this up, this and that up, the character up. There you go. So she should be moving fine now. And let's try train her stay. So direction down, left. Okay, so right, left, down, up, right. Stop. Okay, so let's change her, for example, looking left. Okay, she start looking left. So we are correct now, and that should be the end of the tutorial. So thank you for watching. If you watch this long, and I hope you to see you on the next time. So goodbye.